Hello my dear student friends, welcome you all to this video lecture series of network analysis. In the last lecture, we have discussed about Routh Hurwitz criteria to check the stability of the system. Okay, so we have seen a very simple example of that particular Routh Hurwitz criteria. But suppose, what if there is a problem if the first row element of that particular Routh criteria, if it is becoming 0, then we cannot proceed further. Okay, so we are going to check out the case second in which the first element of a particular row is going to become 0. How to proceed or how to solve such kind of problems that we are going to study today. Okay, so that is the first type of again. So Routh Hurwitz criteria, let us write it as Routh Hurwitz criteria. Okay, and let us say case second. Okay, if any one element of the first row of the first column, not row, if it is 0, that is the case. Okay, fine. So let us see one example based on that. Okay, so let us say q of s is, okay, so s raised to 4 plus s cube plus 2s square plus 2s, sorry, 2s square plus 2s plus 5. So this is the polynomial given to you people. Okay, and you are going to apply Routh criteria for this. Okay, and while solving that, your first row or the first column of your this particular Routh criteria array, it is going to become 0. Okay, so let us see how it is going to become 0. Okay, so draw a vertical line. Okay, so highest power we are going to write it, so s raised to 4, s cube, s square, s raised to 1 and 0, s raised to 0. Okay, let us write the first coefficient over here. Okay, then this coefficient 2 will be over here and the 5 will be over here, right? So remaining are, this is going to become over here, this will be over here, right? And as there is no element, so let us write it as 0. You cannot you can skip it. Okay, so you can either write it as 0 or you can keep it as it is blank. Okay, fine. So let us calculate now. This is, let us say, b0, b1, c0 and d0. Okay, like that. So let us first find out b0. So how to find out b0? b0 is nothing but we have to consider the 4 elements, right? Okay, so these are the 4 elements that you are going to consider in order to calculate b0. Okay, so 1, 2, 1, 2 divided by 1. Okay, so calculate it. 2 minus 2 divided by 1. Yes, so this element itself is going to become 0, right? So it is becoming 0. Okay, so we cannot proceed further because this multiplied with this term is going to happen for the next time whenever we are going to calculate c0, right? And it is again divided by 0. So anything divided by 0 is going to become infinity, no? So we cannot solve further. So for that, there is another technique that we are going to check it out. Okay, fine. So let us calculate d1, b1, not d1. So b1 is nothing but we are going to exclude these two elements and we are going to include these two. Okay, so that is nothing but 1, 1, 5, 0. Okay, divided by 1. So what will be the answer? 1 into 5 is 5. 5 divided by 1 is 5. Okay, so this is coming as 5. Is that fine? Okay, but now if I want to calculate C naught, what is the procedure? If I want to calculate C naught, I need to consider these 4 elements, no? Yes, and divided by B naught. But as it is divided by 0, it is leading to infinity. So we are going to assume, this is the one method, we are going to ultimately assume epsilon, a very small arbitrary value. Okay, so we are considering, instead of it is equals to 0, we are considering it is having a arbitrary value as epsilon. Okay, and with respect to that epsilon, we are going to calculate the further process. Okay, that means we are going to neglect that it is 0. Okay, we are assuming that the epsilon value is there, and with respect to that epsilon value, now we are going to calculate it. Okay, so how I can find out a C naught? C naught is nothing but 1 epsilon. So instead of 0, I have used epsilon, right? And 2 5. Is that fine? Divided by again epsilon. So what is the multiplication, or what is the final result? 2 into epsilon minus 5 divided by epsilon. So 2 epsilon minus 5 divided by epsilon. Okay, likewise we can find out this. And okay, so let us write over here, that is nothing but C naught is 2 epsilon minus 5 divided by epsilon. And what will be the value of D naught? This multiplied by this is right now 0. Okay, because no elements are there. So B naught, epsilon into 0 is 0, 1 into 0 is 0, and divided by epsilon. Okay, so anything divided by 0 is, sorry, any value 0 divided by any value is going to become 0 itself, right? Right. So this is going to happen now. Okay, so the next element will be what? This multiplied with this divided by this value. Okay, so that means this is going to become 0, right? This result is going to become 0. Yes, because 0 epsilon into 0 is 0. Okay, 2 epsilon minus 5 divided by epsilon multiplied by 5 divided by this term. Okay, let me calculate, let me show it over here. D naught is nothing but what? Epsilon 5. Now C is nothing but 2 epsilon minus 5 divided by epsilon 0 and divided by C naught, that is nothing but 2 epsilon minus 5 divided by epsilon. Okay, so this multiplied by 5 divided by this value is going to become resulting as 5, no? Yes, so it is going to become 5. Okay, so D naught is coming as 5. Okay, so my final answer can be written as like this. Okay, s raised to 4, s cube, s square, s raised to 1, s raised to 0. Up to s raised to 0 you have to calculate it. Okay, fine. So 1 2 5, then it is 1 2 0, then this is 0 and that we have replaced as epsilon. Okay, then it is 5, then it is going to become 2 epsilon minus 5 divided by epsilon, and this is finally my 5. Okay, so how we are going to comment the stability of this system? When this term is going to become minus, if this 2 epsilon value is less than 5, right, then and then only it is going to become minus value. And if there are some changes into the sign, then we are saying that the system is unstable, right? But the system is stable, the system is said to be stable until and unless 2 epsilon minus 5 divided by epsilon is not a minus value. or negative value. So instead of using minus, let us use negative value. Okay, if it is negative, then this system is unstable. Okay, so if 2 epsilon minus 5 divided by epsilon is negative, then the system will be unstable. Is that fine? Okay, hope the things are clear to you people. Okay, so this is the case number 2 for the Routh Hurwitz criteria. Okay, so if one of the element of your first row of this particular Routh array, if it is 0, then we have to go for the different techniques. We cannot go for the solving as like that we have studied in the previous example. Okay, so in previous example we were getting all the positive values or all the proper values instead of a 0, right? Nowhere we have got the 0 in the first row of our first column of our that Routh criteria, but over here that is the probability of coming of 0 over here at the place of b0, and because of that we couldn't proceed further. So in order to calculate the other values of c0 and d0, okay, so ultimately what we have taken the approach, we have considered a very small value, arbitrary value epsilon, okay, and with respect to that we have calculated other values. Okay, and if that particular epsilon value, if it is greater than this minus 5, then definitely this system will be stable, and if this 2 epsilon value is less than 5, then definitely it will be an unstable system. Okay, so we can say that this is a marginally stable system. It is dependent on epsilon value. Okay, fine. So there is another way to solve this similar kind of technique is like this. Okay, so consider this equation, same equation. Okay, so this is first approach. Okay, you can call this as approach number 1. Okay, and we'll see approach number 2. Approach number 1 to solve such kind of problems, and let us discuss approach number 2 to solve such kind of problems. Let us write again that particular polynomial equation, s raised to 4 plus s cube plus 2s square plus 2s plus 5 is equals to 0. Now let it be. Okay, so instead of s, at s put 1 by z. Okay, so wherever there is a s, you just put it as 1 by z, and we'll go for solving the same kind of thing. Okay, so s raised to 4 is nothing but 1 by z raised to 4 plus 1 by z cube. So wherever there is s, you are putting 1 by z. Okay, so this is another approach that we are going to use, plus 2s not s 1 by z plus 5 is equals to 0. Is that fine? Okay, now 1 by z raised to 4 plus 1 by z cube plus 2 by z square plus 2 by z plus 5. Now we need to make the denominators common, right? So ultimately we need to make denominator as z raised to 4, because the highest power of z is what? It is z raised to 4. Okay, so we need to have everywhere that is denominator must be have z raised to 4. Okay, so over here there is no problem. I can have 1 divided by z raised to 4 plus z divided by z raised to 4, because we have multiplied and divided by z to this particular term. Okay, then 2z square divided by z raised to 4. Okay, So we have multiplied and divided by z square over here plus 2z cube divided by z raised to 4 plus 5z raised to 4 divided by z raised to 4 is equals to 0. Now this denominator is same. Okay, so I can add it. Okay, so I can add the numerator values. Okay, so this is my new polynomial equation. Now transfer this z raised to 4 to the right hand side and it is multiplied with 0, so that's why it is going to become 0. Okay, so this new modified equation, that is nothing but new modified polynomial equation, will have 5z raised to 4 plus 2z cube plus 2z square plus z plus 1 is equals to 0. So let us say this is nothing but modified polynomial equation m of s. Okay, and we are going to apply similar kind of process as we have applied for the that particular polynomial equation, that is while solving the Routh criteria. So now z raised to 4 over here, instead of s we are using everywhere as a z. Okay, so again we are going to find out that particular Routh criteria matrix or array. Okay, so 5 will be over here as it is, then 2, and then lastly 1. Okay, we have taken this term, and this term, alternate terms. Now let us take this and this. Okay, so 2 and 1, and this is, there is no value, so we can consider it as 0. Okay, now 2 into 2 minus 5. Okay, so 4 minus 5 divided by 2 is coming as 4 minus 5 is 1 divided by 2. Sorry, yes. So minus 0.5 will be the value over here, isn't it? Minus 0.5 is the value over here, and let us compute this value then. Okay, so in order to compute this value, okay, over here we are going to compute b1, no? So this multiplied with 1, this multiplied with 0, okay, and divided by 2 again. Fine, so this value is coming as plus 1. Is that fine? Okay, now let us compute the C0 value. Okay, how to compute it? 0.5 minus 0.5 multiplied with 1 minus 2 into 1 divided by 0.5. Okay, so minus 0.5 multiplied with 1, it is going to become 0.5 only, minus 2 divided by minus 0.5. Is that fine? So this value is resulting, the numerator is resulting as what it is? It is nothing but minus 2.5 divided by 0.5. Yes or no? Okay, and the next values are going to become 0. So this value is going to become 0. That means C1 is going to become 0. Okay, and now what is the value of this one? Okay, so let us compute this. .5 divided by 0.5. It is coming as 5. Okay, so this C0 is coming as 5. And next 5 into 1 divided by 5, it is coming as D0. D0 is coming as 1. Okay, so my final result is coming as z raised to 4, z cube, z square, z1, z0. It is coming as 5, 2, 1, 2, 1, 0. This is coming as minus 0.5. So there is a change in a sign. Okay, so minus 0.5, 1. This was coming as your 5, and this is 0, and this is 1 because this multiplied with this, and then it is coming as 1. Okay, so how many times sign change is there? Plus to minus 1 times, then minus to plus 2 times. So as there are 2 times change in a sign, the system is unstable. As there are sign changes 2 times, occurred 2 times, so the system is unstable. So the system is unstable. Okay, I hope you understood this. Okay, so this is the second case of your Routh criteria example. Okay, now let us see the third case. Suppose if there are two zeros in this particular rows. Okay, so say the z square row becomes, all the elements of the z square row becomes 0. Then how to proceed for such kind of example? That case we are going to discuss now. Okay, so let us discuss that. Let us go to the new page. Okay, so case number third. If any of the if all the elements of the row, not any, if all the elements of a row becomes 0, that is the third case. Okay, so say example number 3, let us say 1. Okay, so q of s is equals to, let us take this example, q of s is equals to s raised to 6 plus s raised to 5 plus 5s4 s raised to 4 plus 3s cube 2s square minus 4s minus 8 is equals to 0. So suppose this is the equation given to you people, and you have been asked to apply the Routh criteria for such polynomial equation. So what you are going to proceed? You are going to draw the vertical line, and starting from highest power of s, you are going to write it. Okay, so let us write the coefficients. Let us write the first column, first row. It is coming as 1. Okay, so let me mark it. These are the elements that we are going to consider for the first column, first row. Okay, and then these are the sum elements which are going to appear for the second row. Okay, so let me write it. 1, then 5, then 2, and then minus 8. Okay, this is nothing but your 1, okay, then 3, 2, and 4. Sorry, it is 5. Yes, 3. Sorry. 1, 3, 4. Yes, 1, 3, 4. Sorry, I made a mistake over here. This must not be there. This is 4 over here. Sorry. Okay. So 1 is over here, 3 is over here, and the last one is nothing but 4 is over here. Okay. And for this, 1 is over here, 5 is over here, 2 is over here, and finally that minus 8 is over here. That's it. You can write it as 0 or you can keep it blank. Okay, is that fine? Great. Now let us find out these values now. Okay, so let us find out b naught. Okay, let me write it b naught over here. How to find out b naught? B naught is nothing but 15313 divided by 1. Okay, how much it is? Sorry, 1 minus 1 into 5, 5 minus 3 divided by 1, it is coming as 2. Am I right? So let me write it as 2. So it is coming as 2. Let us find out b1. b1 is nothing but, okay, now 1, 2 and 1, 4 divided by 1. Okay, so 2 minus 4 divided by 1, so it is coming as minus 2. Is that fine? 2 minus 4, yes, minus 2 divided by 1 is minus 2. Now let us find out this last element, that is nothing but b1, b2. Okay, so for that you need to consider b2 is equals to 1 minus 8, 1 and 0 divided by 1. So how much it is? Minus 8. Okay, so this will be coming as minus 8. Wait a minute. Oh, this is minus 4, no? So sorry, it has to be minus 4 over here. Okay, so 2 minus minus 4, it is going to become 6, no? Okay, so it is going to become 6 over here. Sorry for the mistake. So this must not be, this is 6. Got it? Okay, I hope it is clear. Okay, so the value 1 into 2 is 2. Okay, and then 1 into 2 is 2. Wait a minute. Okay, 1 into 2 is 2. What is happening with this? And 1 into minus 4 is minus 4. So minus of minus 4 is becoming plus 4. Okay, so 2 plus 4, it is going to become 6, no? So that's why it is coming as 6. I hope now it is clear. Is that fine? Okay, now let us find out C1 and C2. So this is nothing but my C1, sorry, C0 and C1. Is that fine? Okay, let us find it out then. Let me change the color. So C1 is, C0 is over here. How to find out C0? So the elements are nothing but 1, 3, 2, 6. 1, 3, 2, 6 divided by 2. Okay, how much it is coming? 2 into 3 is 6. 6 minus 6 divided by 2. It is going to become 0. Yes. So right now it is 0. And let us find out now this one. Okay, so C1 is 1, 2, minus 4, minus 8 divided by 2 again. Okay, so 2 into minus 4, it is minus 8. Minus 8 into 1 is minus 8 and minus of that value. Okay, so this is also resulting to 0. Now can we solve further? We cannot solve it further, isn't it? Okay, because all the values are 0. And but how to find out the D0 and D1? Can we find it out? Because all the values of this particular row is now becoming 0. So S3 row has become 0. It has become 0. Yes. all the elements of this row have now became 0. Is that fine? So how to proceed then? So we need to take a auxiliary polynomial equation. Okay, so let us check out how to create this auxiliary polynomial equation. You need to consider, okay, you need to consider its previous row, okay, and you have to create a polynomial equation from that. Okay, so let us say auxiliary polynomial equation is, as this is the row of s raised to 4, as this is the row of s raised to 4, this element will have, or this coefficient will be have multiplier as s raised to 4, then one gap, that is s cube, will not be there in this particular equation. Then this 6 will be multiplied with s square, because we used to have a alternate coefficient values. Okay, so let us create this equation from this particular row now, and that is nothing but my auxiliary equation. So 2 into s raised to 4, okay, because this is s raised to 4 row, right? So that's why this is nothing but the coefficient will be multiplied with s raised to 4, plus we used to skip alternate element, right? So because of that, the 6 will be multiplied with s square, not s. So 6 will be multiplied with s square and minus 8 s raised to 0. So alternate. Okay, so we can remember that if this particular row is having s raised to 4, so you can use even numbers only. Okay, if that alternate number or s raised to power is odd, then you can use odd numbers series. Okay, so odd numbers raised to powers. Is that fine? Okay, so now let us take a derivative of this auxiliary equation with respect to s. Okay, so what is going to happen? 2 into 4 s cube plus 2 into 6 s, and s raised to 0 means it is simply 1, right? So derivative of constant value is 0, isn't it? Yes. So therefore 8 s cube s cube, after simplification it is going to become 8 s cube plus 12 s. Okay, so I hope this is the row of your s. I hope this is the row of s cube, isn't it? So can I place these newly calculated values of your s cube and 12s? Okay, because this is representing s cube value and this is representing the value of s. Okay, so like that we are going to change the values over here and we are going to proceed to calculate the further values. I hope you understood this method. Okay, if the entire element of that particular row is 0, then you have to consider the previous row elements and you are going to consider its raised to power. Okay, so whatever the coefficients are there, you just multiply that coefficients with the s raised to power with the alternate values. Okay, and then you just take the derivative of that, and whatever the derivative values coefficients are there, you just put it at the place of that particular both zeros values. Okay, and then you just compute as it is the other values as we used to proceed further. Okay, so let us do that. I hope you understood this. Okay, so let us write this over here. So now s raised to 5, not s cube, I think is starting from s raised to 6. Yes, sorry, s raised to 6, s raised to 5, s raised to 4, s cube. Okay, 1 5 2 minus 8 as it is, 1 3 minus 4 as it is, then 2 6 4 minus 8, whatever we have calculated will be as it is. Now at the place of s cube row we are going to put these values as 8 and 12. Are you getting it? We have inserted these values over here. Okay, 8 and 12, and now we are going to calculate rest of other values as it is, as we used to compute the values. Okay, now let us say s square, s raised to 1, s raised to 0. That will be calculated as it is. Okay, so let us compute that. Now in order to calculate this value, we need to consider these 4 elements. Yes, so 8 into 6 minus 24. Okay, so let us calculate. Let us say this is nothing but my d naught. Okay, so let us calculate d naught. D naught is equals to 2, 6, 8, 12 divided by 8. Okay, so 8 6s are 48 minus 12 2s are 24 divided by 8. How much it will be? 24, right? So 48 minus 24 is 24. 24 divided by 8 is 3. Okay, so d naught is coming as 3. Let us compute this one, and then it is going to come definitely as minus 8. Okay, 8 into minus 8, it is going to become minus 64, or you can keep it as it is, and it is also divided by 8, so that's why minus 8 will be the answer. Okay, fine. Now next, if I want to calculate the other E1, E0 and E1, okay, so E0, let us compute E0 over here. 8, 3, 12 minus 8, is that fine? Divided by 3. Okay, 12 3s are 36, minus minus it is going to become plus because this minus is over here. Okay, 64 divided by 3. So let us check out the value. 36 plus 64, 100 divided by 3. It is coming as 33.33. Okay, as there are no values over here, so it is going to become 0. And lastly, let us compute this f0. F0 will be this multiplied with this divided by 33.33. So it is coming as definitely minus 8. Okay, so remember that. Okay, now can you comment on the stability of this system? Check it out. So focus on this particular first row. Is there any sign change? Yes, it is. Where it is? It is at the last position of, or the last row of that particular Routh array, right? So that's why this system is unstable, isn't it? The system is unstable as there is a single sign change. So as there is a sign change, hence the system is unstable. Okay, so likewise you can apply the Routh Hurwitz criteria to such kind of polynomial equations, and there are 3 cases. If there is no any 0, you can directly solve as it is, there is no problem. The second case is nothing but what? If any of the element of a particular row, that means most probably if it is 0 at the first place of that particular column of your row. Okay, so first column, if the element of your first column is 0, then you have to either go for putting any arbitrary value epsilon, then solve as we used to solve this, or else you can go for putting 1 by z instead of s. So at the place of s you are going to put it as 1 by z, and then you can solve that as usual as that we used to solve for Routh Hurwitz criteria. So that is the second case. Third case is what? If the entire elements of a particular row is 0, then you have to consider the previous row and you have to create the polynomial equation, that is subpolynomial equation, that is called as an auxiliary equation. Okay, so auxiliary equation you are going to create, and to that auxiliary equation you are going to apply derivative with respect to s. You have to find out the derivative with respect to s, and you just put the values of derivatives. Okay, after finding out the derivative, you just put the values as a suffix over there. Okay, and then solve as usual that you used to apply for Routh Hurwitz criteria. That is the case. These are the three different cases over here. Okay, and likewise you can check out which type of example it is, and we can apply this process. Okay, and you can find out the stability of the system by using this analytical method. I hope you understood all the cases. Okay, so we'll conclude over here in this lecture, and we'll see next chapter in the next lecture. Okay, thank you so much.